In this video, we are going to explore a particle motion problem. So Peggy is stopped at the top of a steep hill in Seattle. As her traffic light turns green, her car rolls backwards a little before moving forward. If her velocity is given by v of t equals 10t squared minus 8t, where t is in feet per second, what is the displacement of her car to the nearest tenth of a foot at the end of 2 seconds? So this question can seem a little bit tricky because you have this, her car rolls backwards a little bit before moving forward. And then you have this velocity function, but really what you're searching for is displacement. And what does displacement mean in the context of this problem? So displacement will be the total amount that her car has gone by the time she actually starts. And so that rolling backwards a little bit actually isn't going to play into the mathematics piece of it. That is some extraneous information or just something to get your brain thinking a little bit. What does matter is our velocity function. And so before we actually get down to tackling this problem, let's think about particle motion problems. So particle motion problems, we know that S of t is our position function. S of t, this is our position function. That is where is the particle at. When you take the derivative of S of t, that ends up being a rate of change. And that derivative ends up actually being, the amount that it's moved. So the amount that it's moved over the amount of time that it took to get there, right? And that is velocity. This is a velocity function. Now, if you take the derivative of the velocity function, what you get is the amount something is moved divided by time. And that ends up being acceleration. That's our acceleration function. And so that's important. That's important to know that we're going to go position to velocity to acceleration. I'm going to write this a little bit prettier. I like to write it so that you can see exactly what it is. But let's go ahead and just write it a little bit prettier so that we don't use as much space here. So we have our position function, and then the derivative of the position function is the velocity. And then the derivative of the velocity function, or let's actually do it one better, the second derivative of the position function would be the first derivative of the velocity function, which is the acceleration function. So that's pretty cool. That means that if you were to work the other direction, if you were to start at acceleration, the integral of the acceleration function is the velocity function. And the integral of the velocity function is the position function. And of course, you'd have a plus c here, unless you're doing a definite integral. So let's put that all to use in this problem. Peggy is stopped at the top of a steep hill in Seattle. As her traffic light turns green, her car rolls backward a little bit before moving forward. It makes sense, we're in Seattle. If her velocity is given by v of t equals 10t squared minus 8t, where t is feet per second, what is the displacement of her car? Displacement is going to be similar to position here. It's going to be the total amount that she moves. Now, because she's rolling backwards a little bit and then forward, the displacement would be that total amount. So what we need to do is we need to say, well, the position is equal to the integral of the velocity function. And we have the velocity function. So let's go ahead and integrate 10t squared minus 8t dt. When we integrate that, we are going to increase the exponent by 1 and divide by that new exponent. So we'd have 10 thirds t cubed minus, increase this by 1, 8 divided by 2 is 4t squared. And really, we'd have a plus c here. Now, we either have a plus c there, and we have to take into consideration our initial, which would be at 2 seconds, how fast are we going? Or we can say, well, we're integrating this from 0 to 2. And if I integrate this from 0 to 2, that changes things a little bit. I'd say, okay, 0 to 2, I no longer need this plus c. Rather, I'm going to evaluate this integral from 0 to 2, 0 seconds to 2 seconds. Now it's a definite integral. I don't need to know what c is. So let's go ahead and plug in our 0 and 2. So we have 10 thirds times 2 cubed minus 4 times 2 squared minus 10 thirds. I'm going to put a 0 in there. 10 thirds times 0 cubed minus 4 times 0 squared. Well, this whole piece is just 0. That whole piece is just 0. So really all I care about is this piece here. 2 cubed is 8, so I'm going to have 80 thirds minus 2 squared is 4. 4 times 4 is 16. So I would have to convert that into thirds, or we can plug it into our handy dandy calculator. And we get 10 and 2 thirds. So this is going to be 10 and 2 thirds. But we have to pay attention to the question. And the question says to the nearest tenth of a foot. 2 thirds is not a tenth of a foot. And so our answer is going to be 10.7. That's a tenth of a foot, feet. And you want to make sure you include your units here. You want to make sure you're really clear the units are feet. And so that's where I'm going to put my answer.